Hello guys, today I'm going to be covering climate change and basically the information about it. We're going to talk about the ozone layer, solutions to climate change, what's causing climate change, talk about a bit about the greenhouse effect, a bit of everything. Just a quick overview over what is climate change and how does it really work. And we're going to start with the ozone depletion, where we really started getting worried about climate change as general when we started seeing depleting of the ozone layer in our atmosphere. And our atmosphere is made up of various different layers, all of which respond differently to human interaction. And here we can see the layers from inwards to outwards. We got the troposphere, stratosphere, mesosphere, thermosphere, and then even beyond the thermosphere you have the exosphere as well, which is basically space at that point. Where we live is down at the troposphere. Down there, that's where we have our mountains, that's where we fly most of our planes and other objects, that's where we have most clouds. But the stratosphere has been getting a bit of attention recently because of the ozone layer that lies within the stratosphere. And the ozone layer is obviously incredibly important. And so, the Montreal Protocol was set out to protect the ozone layer in the late 1980s. And all nations in the UN ratified the protocol, which means it was basically a unanimous decision to protect the ozone layer. And it worked by pledging to reduce the amount of CFCs or chlorofluorocarbons that were commonly found in aerosol cans and refrigerators. We basically reduced that, which was destroying the ozone, and that would slow down the depletion of the ozone layer, and eventually their hope was to reverse it back to normal levels. But why did they put such an effort into protecting the ozone? Well, ozone is important because it protects us from radiation. At least stratospheric ozone is important because it protects us from radiation. Because the thing is, there are two different types of ozone. There are stratospheric ozone and then tropospheric ozone, the bad ozone and the good ozone. The good ozone can be found in the stratosphere, in the ozone layer, but the bad ozone can be found in the troposphere. And here, it's made up by our cars, by our factories, and it can be a pollutant. It can mess with your lungs, make you feel all kinds of sick. So we don't want the bad ozone here in the troposphere, we want the good one in the stratosphere. And that's what we're trying to protect, because it protects us. And that's what the Montreal Protocol is trying to achieve. And we can obviously mitigate the amount of bad ozone that we produce by mitigating our usage of vehicles, mitigating our factories, trying to use less energy. Basically the things that reduce the amount of greenhouse gases will also help reduce the amount of ground level ozone. And as far as fixing the hole in the ozone layer, the reduction of CFCs has stopped the deterioration, so it's no longer, the hole isn't getting bigger anymore. And we hope that with time, the ozone layer will continue to grow as it is right now and grow back to its original size. That's the hope. So far it's good. Now we're moving on to the causes of climate change. What's causing climate change? Well, really what's causing climate change is the greenhouse effect and the greenhouse gases that lie within it. Basically, you have sunlight, and it strikes down, hitting Earth, and most of it normally gets reflected back by whether it be the water or the ice caps, just because sunlight is going to bounce off there. However, because of some gases in Earth's atmosphere, the sun's rays hit the Earth, bounce back up, but then hit more particles. And those particles keep the sun's rays from leaving, and that keeps the sun's heat inside the atmosphere, leading to obviously more heat inside the atmosphere. And these greenhouses can include water vapor, methane, carbon dioxide, nitrous oxide, chlorofluorocarbons, hydrofluorocarbons, many more. There's plenty of greenhouse gases. But as far as human production is concerned, we produce roughly 83% carbon dioxide, 10% methane, 5% nitrous oxide, and 2% fluorinated gases. And these trap the heat in our atmosphere. That is the greenhouse effect. And the EPA does regulate some of these pollutants. They regulate ground level ozone, carbon monoxide, lead, sulfur dioxide, nitrogen dioxide, and some airborne particulates. And that's good for public safety. However, they could be doing a better job regulating some stuff like CO2, which is an obvious greenhouse gas. But that's just hoping for the future. The thing is that the air pollutants that they're currently targeting is more of a matter of public safety than trying to prevent climate change, and that's obviously important as well, public safety. We have to keep the big picture in mind as well. Some people like to say that, well, climate change is a hoax, it isn't real, it's just happening naturally. Well, if we look at El Nino and La Nina, some natural oscillations of the climate in our world, these are actual climate phases, but even then, they have their limits. They switch between La Nina, which is a cold water phase, and El Nino, which is a hot water phase. But there's never been as hot in El Nino as there is right now. It can't be caused by that. It's never been, the temperature in the ocean waters has never been increased by El Nino as much as it is right now. And that's worrying, because we can't just blame it all on natural oscillation when obviously we're influencing a factor. And when the statistics show that temperatures have never been higher, we can't say, well, it's been like this all along. Obviously not. Obviously not. But fossil fuels do have their advantages. That's why we keep using them. If fossil fuels were completely terrible at everything, we wouldn't be using them. They do have their advantages. They do provide jobs. They're good in energy condensation. You barely need any coal to heat up and get lots of energy out of it. It's very packed and energy dense, and you have tons of reserves. Literal tons of reserves. You can find coal anywhere, and it's cheap and easy to extract. However, while they do have those advantages, and oil is used basically in every motor vehicle that we have, and natural gas is plentiful and clean burning, relatively, of course, they do contribute to greenhouse effect very heavily in the case of coal and oil, and that's not good. And in the term of coal and natural gas, they lead to environmental degradation, which can lead to surface runoff and increased flooding as well, which are other environmental factors that you don't want to have as part of, obviously, your fuel source. So if we can get off of them over time, that would be just beneficial to society as a whole. But now we're going to talk about the effects of global climate change. What is going wrong with our world because we're heating? And really, it comes down to, it's only going to get worse if we keep on going in this direction. Because climate change is a positive feedback loop. The more greenhouse gases we put into the atmosphere, the more naturally polluted greenhouse gases are made. You get more because you put in more, and it keeps on cycling, and eventually it's going to go out of control. We can see this in Venus, where the greenhouse effect has made it literally the hottest planet in our solar system, despite that Mercury is far closer to the sun than Venus is. The greenhouse effect has led to so much cloud formation that the pressure on Venus crushes you, despite the fact that its gravity isn't all that different from Earth's. So there is something that we have to fear here, that we have to be worried about, because if we continue on this positive feedback loop, it's eventually going to become too strong to break, and by then it'll be too late, not just for us, but for everybody after us as well. Then we have smog. Smog is also caused by this greenhouse effect and by this global warming as a whole, by this climate change. And there's two different types of smog, similar to how there's two different types of ozone. You have industrial smog, which is kind of like the black sooty smog that used to be in London and New York and most industrial cities during the Industrial Revolution era, and that's caused by burning of coal. Burning of coal releases sulfur, sulfur builds up and creates that soot, and that's where you get that black, stinky smog from. However, one that's a bit more noticeable today, a bit more relevant today, I would imagine, is in photochemical smog. Photochemical smog, that's actually created by nitrous oxides, actually, coming from cars and motor vehicles, usually during transit days, or sorry about that, and in sunny days, when lots of people are out. The fumes from the car build up, and the sun's rays activate the nitrous oxides, and you get this yellowish haze over cities. And you can see this in LA, Shanghai, in particular. Mexico City also has quite a bit of photochemical smog. And now we're going to be talking about the runaway greenhouse effect, which is simply what I was mentioning earlier with the positive feedback. It's like more pollution, more greenhouse gas equals more temperature, and more temperature equals more pollution, more greenhouse gas, which therefore equals more temperature. It's out of control. It's already gone up more than half a degree, the global temperature. 2 degrees Fahrenheit since 1900. Sorry, not half a degree. And the temperature's only looking to rise even more. And this isn't something natural. This is something that we have influenced. Temperatures have never spiked as much in so little time as they have today. And this is unlikely to be coming from the sun, as done research by NASA. This increased temperature also leads to more precipitation, which leads to flooding, which leads to those big storms that you've been hearing about. Climate is imbalanced, and while there's more precipitation, it might be, good. Like, oh yes, people with drought are going to be getting more rainfall. That's good. No, not exactly. This more precipitation is coming in the form of big storms. It's coming in the form of flood. It's coming in the form of blizzards. It's not coming in the form of even rain throughout. That's not how climate necessarily works. But the increased precipitation, the increased rainfall is leading to these bigger storms, bigger natural disasters. And it's going to eventually costing us more money. We need to reduce the temperature, to reduce the precipitation. To reduce the temperature, we need to reduce greenhouse gases. To reduce greenhouse gases, we need to reduce fossil fuel emissions. That's what it comes down to. Also, with more precipitation comes rises in sea levels. And this is also caused by the melting of polar ice caps, which is caused by temperature increases. And sea level changes can be drastic. Even just 2 or 3 feet in a lot of the cities that we love so much, they're completely ruined. Because this water is getting into them and it's messing with the city completely. Venice is especially scary. But even places like New York, San Francisco, Shanghai, who are built on those coastal areas, will suffer from even small things like 2 to 3 feet. I mean, it's already been over half a foot from the 1800s to now. It's already increased by half a foot, and that's looking to continue to be rising. And this is because of changes in global ice too. Changes in global ice, they're melting. That melting leads to obviously more sea level rising, and obviously when you get more sea level rising, you get more flooding and stuff. But interestingly, melting of the polar ice caps also has the increased effect of less sun is being reflected back out into the atmosphere, which means we get even more sunlight absorbed. So it even contributes to the greenhouse effect when we get less ice, and that's obviously not good. And unfortunately, it also leads us to changes in biota, which is basically our natural biodiversity. We're going to lose some keystone species. We're going to lose some important species. Everybody knows about the polar bear, but more importantly, coral. Coral are being incredibly devastated by these attacks, by this climate change. They're just not being able to adapt. And coral reefs are harbors for natural biodiversity, basically rainforest in the ocean. They're incredible. And without the coral there, you're going to lose a lot of other species, and that's going to be a chain reaction throughout the entire ocean ecosystem. But could we have predicted this? Yeah, we've been predicting. As with proxy indicators, with these ice cores, with ocean sediment samples, with coral deposition, with pollen tracking, tree rings, we've been able to see the temperature and the climate throughout the years. That's how we know it's probably not the sun that's heating up. No. That's how we know that this isn't some natural thing, because we can look at our past and say, has this ever happened before at this rate? No, it hasn't. And that's the thing. We need to act based on what we see, because right now we're in a state of shock, but we're not acting at all. So what can we do? What are the solutions to climate change? Well, the Kyoto Protocol was a good start, one that unfortunately didn't go so well. It attempted to get targets for nations to follow to reduce CO2, and that's okay. That's a step in the right direction. But while every United Nation signed the Kyoto Protocol, I'm sorry, not every nation really followed it the way it should have. They had loopholes with carbon offsets, and some people didn't even set targets for themselves. So while it was meant to reduce CO2 concentrations, by the time the Kyoto Protocol, the first phase has ended, the carbon concentration went up drastically. So it hadn't really done its job, but it was a step in the right direction. And speaking of carbon offsets is a way for a company or a state basically to say, no, we don't want to reduce our CO2 levels right now. However, we will put the money that we would pay because of the CO2 fine, and we're going to put it into a thing that will absorb CO2, whether that be a farm or a windmill, some sort of solar power plant. Basically helps reduce overall emissions, even if they can't reduce their own CO2 emissions that they're pumping out into the atmosphere. And this helps. This is a good start. However, this needs to be coupled as well with actually reducing the CO2 operated by factories. We can't just rely on carbon offsets alone. That's not a wise decision. Furthermore, we need to implement major renewable fuel types. This is the big thing. Renewable energy. We're talking about tidal energy, wind energy, solar, geothermal. these are the big things that are happening right now. Because we can get off coal, we can cut off that positive feedback loop, and eventually it will begin to stabilize again. And this is the way that we can cut off coal, that we can get our dependence off of fossil fuels and work towards a cleaner form of energy. And while a lot of them are promising, tidal is clean and compact, a lot of them are relatively new and expensive to implement. However, with time, we will only get better, because we have to get better. Right now, if we continue at this certain rate that we're going, we're going to have huge sea level increases, enormous temperature increases, loss of biodiversity. It's going to be unacceptable, especially when we have the solution right in front of us. So I hope you guys learned a few things about climate change. I hope that you guys know just a bit more today. See you guys.